Okay, in this video we're going to talk about, in Chapter 9, fractions as operators. So in the operator interpretation of rational numbers, we can think of rational numbers as functions. Okay, so that's a pretty advanced topic. The operator notion is all about shrinking and enlarging, contracting and expanding, etc., etc. So operators are transformers that either lengthen or shorten line segments, increase or decrease the number of items in a set of discrete objects, or take a figure in the geometric plane, such as a triangle or a rectangle, and map it onto larger or smaller figures of the same shape. Okay, an example. Okay, 2/3 of, so that's an expression, is an operator that instructs you to multiply by 2 and then divide by 3. Note, the order does not matter, so you could also have divided by 3 and multiplied by 2. So in the operator interpretation, the significant relationship is the comparison between the quantity resulting from an operation and the quantity that is acted upon. So the operator defines the relationship. Okay, so you have an input, it's acted upon, and then you get an output. So in fact, these are those little machines that a lot of times they'll use when they are working with functions. So they're calling them exchange models. The input-output relationship suggests the connection of the operator to functions. Okay, the operator 2/3 of explains the relationship between the sets given in the table. So the input is 6, and 2/3 of 6 is 4. When the input is 9, 2/3 of 9 is 6, and on and on. Okay, so this relationship can be pictured as a machine as well. So what is that relationship? So you have 5, and when it comes out, it's now 2.5. Well, so the operator must have been 1/2 in that situation. Here you had 5, and when it came out, it was 2. So the operator in that situation is 2/5. So if you do the math, 5 times 2/5 gives me 2. And that's how I know my operator is 2/5. Likewise, 5 times 1/2 gives me 5/2, which is equivalent to 2.5. So that's how I know my operator is 1/2. Okay, an example of an exchange model presented as a word problem. Okay, so this is really something that the kids will build towards. Harry and Dan agree that 3 chocolate bars for 5 packs of gum is a fair exchange. If Dan gives Harry 42 chocolate bars, how many packs of gum should Harry give Dan? So let's first find out what the operator is. So initially, we were looking at 3 chocolate bars for 4. So if I take 3, what do I multiply it by to get 4? When you multiply it by 4/3, you will get 4 back. So 4/3 is your operator. Okay, so 4/3 is your operator. So if the operator acts upon the input of 42, 42 times 4/3, that's what gives me the 56. Okay, so these are pretty advanced topics, but they're doing it at a lower level so that, your grade school, elementary school, middle school kids can understand this. Composition. When you perform some operation and then perform another operation on the result of the first operation, you are able to compose operations or do a single operation that's a combination of the two. And that's what a composition is. Okay, again, as you get higher in math, you have more advanced types of compositions, but that's the essence of it. So an example, you enlarge a picture to 80% of its original size, and later learn that you were supposed to enlarge it by 20%, not reduce it by 20%. Unfortunately, you lost the original. What can you do to the 80% copy to obtain a copy that is 120% of the original size? Okay, so let's think about this. you have to do something to your 4/5, okay? 4/5 is what the current size is. When you reduce 80 over 100, it reduces to 4/5. Okay, you want to operate on it, do some operation, so that when you're done, the final result is 120 over 100, which reduces to 6 over 5. So the final result has to be 6 over 5. Okay, so it looks to me that we can figure out what that's going to be by just doing a little bit of math. Now I should back up for a second and say, since multiplication is commutative, you can do it in either order. So what if you multiply by 6/5? Would that, with 6/4, would that give you back what you need? And I think the answer is going to be yes. Okay, so what's going to happen there? You're going to end up with 6/5. So 6/4 is your operator. So the operator is what you're going to put on the copy machine so that you get the right size copy. So what does 6/4 equal in terms of percentages? So 25 times 4 is 100, and 25 times 6 is 150. So that's 150%. That's what you're going to put on your copy machine to get the original back. Okay, so let's go on to the next page. Okay, area model for multiplication. The composition of operators leads very naturally to fraction multiplication. For example, 2/3 of 3/4 means take 2/3 of 3/4 of a unit. So I have to do this over 2 pages, so bear with me. So 2/3 times 3/4. To do this, first you have a hole, and you're going to represent the unit area and shade 3/4 of it. So now you have 3/4 of that. Now the operator 2/3 of will operate on the result obtained by applying the operator 3/4 of. That is, we'll take 2/3 of 3/4 of 1. Okay, so we're going to take 2/3 of 3/4 of 1. That's complicated. We use vertical divisions to show the first operator, and now on the next page we're going to show the second operator. So here's your second operator. So your first operator was the verticals, so that was these. Your second operator is going this way. Okay, so then the question is, it says, let's keep reading. Notice that the unit consists of 12 small rectangles. So the double shaded region is 6/12. So let's back up a little bit. So what did we do? We then, now the operator 2/3 of will operate on the result. So we took 2/3 of this, and that's how this got double shaded. Notice that the unit consists of 12 small rectangles, so the double shaded region is, so count 6 over 12 is 6/12. If you do some visual rearranging of the double shaded pieces, you will see a way to rename it. And basically, you can rename it as 1/2. Okay? So that's that. Let's go on to the next page. Now you want to do an area model for division. So the previous one was the area model for multiplication. So here's division. Division may also be interpreted as the composition of 2 operators and may be modeled using an area model. So 3/4 divided by 2/3. So the division answers the question, how many 2/3 are there in 3/4? So here's your unit. First shade 3/4 of it. In the horizontal direction, divide the unit into thirds, but do not shade. Okay, we're not multiplying. Don't shade it. How much is 2/3 of 1? So think about that. What's 2/3 of 1? So you should be saying that 2/3 of 1, if this is 1 whole, 2/3 of 1 are 8 squares. So our division question becomes, how many times can we measure an area of 2/3, or 8 small squares, out of the shaded area represented 3/4? So let me go to the next page so I can see this better. Okay, so you know that 2/3 of a whole is the 8 squares. So here is 1, 2, 3, 4, 5, 6, 7, 8. So you can put it in, that's 8 squares, one time, and then you have 1 square left, so you have 1/8. Now, does this match our normal algorithm for division? So 2/3 divided by, excuse me, let me write down the correct equation. So 3/4 divided by 2/3. And to do that problem, you would say 3/4 times 3/2. So that's going to be 9/8, which is 1 1/8. So yes, this is the method we use when we want to do division. Okay, so think about and contrast that with what we did with multiplication. Okay, we can go on to the next page. Okay, paper folding they talk about, and it helps to convey the sense that a composition is a rule describing the result of an action performed on the result of a previous action. It also helps build a base of understanding for fraction multiplication and is particularly effective in demonstrating that a product is not always larger than its factors. Okay, so understanding operators. If a student understands fractions as operators, then what will they understand? So the student can interpret a fractional multiplier in a variety of ways. 3/4 could mean 3 times 1/4 of a unit, but 3/4 can also mean 1/4 of 3 times a unit. When two operations, multiplication and division, are performed, one on the result of the other, the student can name a single fraction to describe the composition operation. So dividing a unit by 4 and then multiplying that result by 3 is the same as multiplying by 3/4. The student can identify the effect of an operator and can state a rule relating inputs and outputs. For example, an input of 9 and an output of 15 results from a 15 for 9 operator. So it's an enlarging operator, and it's symbolized as 15/9. Okay, one last thing. The student can use models to identify a single composition that characterizes a composition of compositions. So 2/3 of 3/4 of a unit is the same as saying 1/2 of a unit. Okay, so now you're ready to look over the activities and look over the problems in the problem set.